Scientists detected a rhythm coming from the sun, a rhythm like a beat. And no, the sun is not secretly a giant space drum, even though it kind of acts like one. The weird part is this: the sun is not solid. It is a huge ball of super hot gas, so how can something like that have a steady pulse at all? And what does it mean for you down here on Earth? To understand this, we have to zoom out, way out, then zoom back in. Because when people hear the sun made a rhythm, they picture a glowing ball going thump, thump, thump like a heart. That image is funny, but the real story is even cooler. Scientists are not hearing sound in space like you hear music in your room. Space is mostly empty, so sound waves do not travel the same way. What they are detecting is a pattern, a repeating motion, a rise and fall, like a hidden wave moving through the sun. Now, before we get to the how, let me remind you what the sun really is. It is not a campfire. It is not a giant burning rock. It is a star, and it is huge. If Earth were the size of a peppercorn, the sun would be a beach ball. That means when the sun does anything, even something that seems small, it can still be massive compared to anything on Earth. So what is this rhythm anyway? Think about a bell. When you hit a bell, it vibrates. It shakes in a pattern. It might ring fast, then slowly fade. That shaking is not random. It follows a rhythm. Now imagine a bell made of glowing gas, gravity, and magnetic forces, and you are starting to get the idea. The sun can vibrate too, not like a metal bell, but like a giant bouncing, rolling ocean of hot plasma. Okay, but how do scientists even detect something like that? They cannot put a microphone near the sun. That would be a very short mission. Instead, they watch the sun's surface very closely. They measure tiny motions, tiny changes in light, and tiny shifts that repeat again and again. It is like watching a flag in the wind. You cannot see the wind itself, but you can see the flag move. In the same way, scientists cannot see waves inside the sun directly, but they can see the surface wobble in a steady pattern. And here is where the story gets even better. The sun is doing this all the time. It is bubbling. It is churning. Hot material rises, cool material sinks, then it rises again. This is called convection, and it is like a pot of soup on a stove. If you have ever stared at boiling water, you know it never stops moving. The sun is basically that, except the stove is nuclear fusion and the soup is plasma hotter than anything you can imagine. So imagine this. Deep inside the sun, energy is being made in the core. That energy pushes outward. On the way out, the sun's material moves, swirls, and slams into itself. All that motion can create waves. Those waves can bounce around inside the sun, like waves in a pool that keep hitting the wall. Some waves travel outward, some get trapped, some bounce back. And when enough of them line up in a repeating way, the sun starts to ring with a pattern. Now you might be thinking, wait, if the sun is always bubbling and exploding and doing solar flares, how can any rhythm stay steady? Great question. Because the sun is messy. It is like a giant weather system that never ends. But even messy systems can have patterns. Earth's ocean is chaotic, yet tides still rise and fall. Your heart beats even when you are running, laughing, or sleeping. Patterns can sit on top of chaos, like a steady drum beat under a loud song. So what does the rhythm look like to scientists? Not like a sound wave on your phone, but closer to a repeating rise and fall in the sun's surface motion. A tiny up and down, a tiny bright and dim. It is the sun's surface breathing in a way that can be measured. And when scientists see the same kind of motion repeating, they call it an oscillation, which is just a fancy word for something that moves back and forth in a pattern. Here's why this matters. The sun's rhythm is not just a cool fact. It is a clue. It tells scientists what is happening inside the sun in places we cannot see. Think of it like this. If you tap on a wall, you can sometimes tell if there is an empty space behind it. The sound changes. If you shake a box, you can guess if something heavy is inside. The sun's rhythm works the same way. By studying the pattern, scientists can learn about the sun's inner layers, how fast they move, how they flow, and how the sun's magnetic field behaves. And the magnetic field is where things start to get spicy, because the sun's magnetism is not calm. It twists, it tangles, it stretches like rubber bands. Sometimes those rubber bands snap and release huge bursts of energy. That is when we get solar flares and giant clouds of charged particles flying out into space. If those particles head toward Earth, they can cause bright auroras, and they can also cause trouble for satellites, power systems, and radio signals. So now you might wonder, is the rhythm connected to those dangerous outbursts? Sometimes the rhythm can help scientists understand the conditions that lead to stronger activity. It is not like if the sun beats faster right before a flare like a cartoon villain. But the rhythm can reveal changes in the sun's internal motion and magnetism, and those internal changes can be connected to how active the sun becomes over time. At this point, you might be asking, why are we only talking about this now? Haven't scientists studied the sun forever? Yes, but the tools keep getting better. Modern instruments can measure tiny details that older telescopes could never detect. Imagine trying to see a small ripple in a pool from a mile away. You would miss it. But with better cameras, better filters, and better data analysis, you can spot the ripple, track it, and prove it is real. Also, the sun is not always doing the same thing. Its activity changes over years. Sometimes there are more sunspots, sometimes fewer. Sometimes the sun is calm, sometimes it is wild. When scientists gather long stretches of data, patterns show up more clearly. A rhythm that seems hidden in 1 week of data can become obvious when you look at months or years. Okay, quick pause, because this is usually where a channel like this takes a breath. If you are enjoying the way we turn big space mysteries into simple stories, this is the perfect time to hit subscribe. You are going to want to be here the next time the universe does something weird, because it always does something weird. Now, let's get back to our sunbeam, because the biggest question is still sitting there. Should you be worried? Here is the good news. The sun having a rhythm does not mean it is about to explode. This rhythm is more like a normal behavior, like waves on the surface of a lake. It is part of how the sun moves energy around. In fact, the rhythm is useful. It is like a health check. If we can measure the sun's patterns well, we can understand it better, and that helps us prepare for the times when the sun gets stormy. But there is also the not so fun news. Even normal sun activity can affect Earth. We live under the sun's constant influence. The sunlight warms our planet, powers plants, and makes life possible. But the sun also sends out radiation and charged particles. Most days, Earth's magnetic field and atmosphere protect us. They are like a shield. But during strong solar storms, that shield gets tested. So imagine you are on Earth during a major solar outburst. Satellites might get hit with extra radiation, GPS can get less accurate, some radio communication can get noisy, power grids can get stressed, and if you are lucky, you might see auroras in places that normally never see them, like a surprise light show in the sky. Now picture the rhythm as a kind of warning system. Not a siren, but a set of measurements. Scientists watch the sun's surface, they track patterns, they compare them over time. They combine this with other observations like sunspots and magnetic loops. All of it helps them build a better picture of what the sun is doing and what it might do next. Let's make this personal for a second. If the sun suddenly stopped having these patterns, that would be weird. If the patterns changed drastically, that would be interesting. It could mean the sun's internal flow shifted. It could mean magnetism is behaving differently. It could mean the engine under the hood is running in a new way. And the sun is basically the biggest engine in our neighborhood. So yes, scientists care a lot about what its engine noise sounds like. Also, there is a cool side effect of all this. Learning the sun's rhythm helps scientists understand other stars too. Because if we can decode the waves of our own star, we can use the same ideas to study distant stars. That means we can learn about stars we cannot visit, stars that might have planets, and stars that might influence life on those planets. In a strange way, the sun's rhythm becomes a guidebook for the whole galaxy. Now, let's do a quick mental experiment, because that is always fun. What if you could stand near the sun and actually feel this rhythm? First, you cannot, because you would be instantly destroyed. But let's pretend you have a magical heat-proof suit. You would not hear a drum. You would not hear a heartbeat. You would see motion, huge rolling pattern, rising bubbles of plasma the size of country, waves moving across the surface, loops of glowing material following magnetic lines. And under all of it, a steady repeating wobble like the sun is breathing. And that is the part that makes this story feel almost alive. A repeating pulse makes humans think of life, but the sun is not alive. It is physics. It is gravity pulling inward while energy pushes outward. It is motion and pressure trying to balance. The rhythm is what happens when a giant system tries to stay stable while still being incredibly active. So when you hear scientists detected a rhythm coming from the sun, the real meaning is this. We are getting better at reading the sun's hidden patterns. We are learning how its surface motion connects to its deep interior. We are building a clearer map of how this star works, and that matters because our entire planet depends on it. And here is the final thought. The sun looks calm when you glance at it in the sky. It looks like the same bright circle every day, but it is not quiet. It is not still. It is a roaring, moving, changing star with waves running through it like a giant cosmic instrument. And now we are finally hearing its beat. Not with ears, but with science. If you want, in the next video we can go one step further and ask a scary question. What would happen if the sun's rhythm changed? Not a little, but a lot. Because if the beat changes, the whole song can change too. And if you want more simple science-based stories like this, subscribe and turn on notifications, because the universe always has a new mystery waiting.